All right, so let's continue our review for the Unit 2 lecture exam by talking about what soil is. So in our previous segment, we talked about what was physical and chemical weathering, which would take a rock and break it down into sediments. So what's going to happen if we take these sediments and then we mix it with organic material? That's where a soil comes from. So you need to know the definition of what a soil is. So it's rock or sediment that has been modified by organic material over time. So here is a summary of this picture here. The different layers of soil, which you need to know for the exam, are going to be the original rock is down here. So this is the parent rock. So because of physical and chemical weathering, it's going to break apart into sediments, smaller pieces of rock and altered minerals. So that's going to be the sea horizon, the weathered rock. Okay, the next thing that's going to happen though is if there's any life, that life is going to start to produce organic materials. So that's going to be the O layer. And that O layer is going to start to mix with the C layer, and then that's going to start to produce the A layer. So the A layer is going to consist of minerals from the weathered rock plus the organic materials such as dead leaves and organisms. So all that organic material gets mixed in with that, with this stuff here, and it starts to make the A layer. Now if you take the O layer and the A layer and you put it together, that's going to be the topsoil. So this is what we plant our crops in. So if you see plants that are springing up out of the ground, they are coming out of the topsoil region. All right, now the next thing that's going to happen though is that as it rains, water is going to be going through this layer here, and it's going to start to eluviate the soil, and it's going to start to leach the soil. So eluviation is a physical process that is going to physically carry clay particles out of the A layer, and then it's going to start to accumulate in the B layer. Leaching is a chemical process that is going to take these minerals that are in the weathered rock and alter them, turn them into clay, and then the clay again is going to be eluviated and carried down into the B layer. So you take this layer A and you subtract the clay from it, then you get the E layer. So the E layer is the place where you have these chemical reactions, and the eluviation is physically moving the material down into the B layer. Now if you overfarm and you destroy your topsoil, so let's say that you use this up because overfarming can break up the topsoil and then rain can carry it off. So the topsoil can be destroyed over time. If you destroy your topsoil and you get down to these layers, you cannot plant crops in the E, B, or C layers. They won't grow. So you need topsoil in order to grow your plants. Okay, what is going to control the rate at which this rock is eventually going to turn into this topsoil? So it's going to depend on the amount of water that you got to work with, because chemical reactions need water, and also a lot of these physical types of weathering require water. So the amount of water that you got is your rainfall, and also what temperatures are you working with. So if it's too cold, everything's going to be frozen, and so you're not going to have good soil formation in a frozen climate. It also is going to depend on what kind of rock do you begin with. So if you have basalt as your original rock, that's going to turn into a different kind of topsoil than what limestone is. It also depends on the topography, so that if you've got a mountain and then a valley down here, you're not going to have so much topsoil on the sides of the mountain because it's just too steep. It's going to carry away all of that material, and it's going to accumulate down here in the valley. So a valley would be a good place to farm because it's going to have thicker topsoil. It's also going to depend on the amount of moisture that is inside the ground, so subsurface moisture. It also depends on the acidity. So acids can break apart rocks. So the acidity of the water inside the ground is also going to determine what kind of topsoil you're going to end up with. Then biological factors. So if you don't have any organic material, you can't turn it into soil. So it depends on what kinds of living organisms are present. And then time. So it takes time to make topsoil. The longer time goes on, the more topsoil that you develop. So what are the different kinds of soils? So here is all of the different kinds of soils, which you don't need to know for the exam. But you do need to know about 3 kinds of topsoils. So the first one is going to be called an arid soil. So let me put that up here. So arid soil. Okay, and so this one is going to form in an arid environment, so like in a desert. So in a desert, you don't have that much rainfall, so you don't have a whole lot of this rock down here changing into good topsoil. You also don't have a whole lot of organic material in a desert. But what you do have, though, is occasionally you do have downpours. And so one of the things that can happen is that if there is limestone down here underneath all of this rock, that limestone can be dissolved by these catastrophic rainfalls that you have. So just know the different layers of a aridisol. Okay, then the second kind is going to be called an alphasol. So that's the middle one, and this is going to occur in a temperate environment. So this one occurs in a desert. This one occurs in a temperate environment where you have forests. And so this is going to produce the best kinds of topsoils. So it tends to have a lot of organic materials that mixes with the weathered rock, so you do tend to get very good topsoils in temperate climates. You also tend to get a lot of oxidation of the soil, and you also do tend to get a lot of leaching, so that you will, if you dig down through the topsoil, you will get to a layer of clay and rust. So you get your clays from the eluviation and the leaching, and then the clays are red in color because of oxidation of the iron minerals that are in there. Okay, then you have the third category over here, which is going to be called an oxy soil. So can you imagine that it has a lot of oxidation going on? So this is going to be in a jungle environment. So this is desert, this is temperate, this is jungle. So in a jungle environment, it's the exact opposite of the desert environment. You have a lot of rainfall going on. And so that rainfall is so heavy that you don't tend to have a very well-developed A horizon. What you do have is a lot of organic material that comes from the jungle. So the plants and animals that live in the jungle make a very thick layer of organic material, but the problem is that the rainfall, when this layer here gets carried off very easily by the rainfall. Now you do, however, have a lot of eluviation and leaching that goes on. So you're going to have a very well-developed clay area in these kinds of soils. And this is where we get bauxite from. So if you recall, bauxite is a sedimentary rock that is composed of clay. And so it came from these kinds of environments. Bauxite contains a lot of aluminum, and aluminum came from that clay. All right, let's take a break, and when we come back, we'll talk about how do humans impact soil.